Hey everybody, this is Husky Hacks. Today I want to go through some of the challenges that I wrote for the Huntress 2023 Cybersecurity Awareness Month Capture the Flag. So I wrote a bunch of these challenges and I wanted to record a couple of videos with just some very nice and easy quick walkthroughs to show the intended solutions for these challenges. So your solution may be a little bit different than mine, but this is the one that I had in mind when I was designing the challenge. So the first one that we're going to start with today, let's go ahead and find it, was a really fun one to watch unfold in the Discord when it was going down. So we're going to talk about Snake Eater today. I had a lot of fun watching everybody try to solve this one and try to approach it and figure it out. So I'm going to show you the intended solution. So right off the bat, let me start by saying this. I think a lot of you, if we're going to use a metaphor here, a lot of you took a grappling hook, took a harness, strapped yourself to the grappling hook, fired the grappling hook up the side of a skyscraper, and started climbing up the side of the building. And I think maybe you didn't realize that there was an elevator right next to wherever you decided to start climbing. And so today I'm going to show you the elevator. Again, that's not necessarily a bad thing. I think some of you went after some very innovative solutions for this one. But let me show you indeed how easy Snake Eater was supposed to be. So we're going to go ahead and bring this over to the desktop. Immediately we see that Snake Eater is an executable, so Windows portable executable, and it's got this interesting icon here. This is a PyInstaller icon. So if you write Python code and you want to package it into a standalone Windows executable so it can run anywhere regardless of if the Python interpreter is installed on that endpoint or not, you can go ahead and make a PyInstaller executable. Now, to start, I think a lot of people tried to decompile this. So really, a Python executable is just kind of Python code wrapped inside of an executable. There is Python code under the hood here. But to get to that, there was something kind of standing in the way of that. So actually, I want to just change directories to the desktop. And if we strings, we can actually see this. So if we strings snakeeater.exe, and I think there should be like a less utility in Windows, right? I guess not. Okay, so if we string snakeeater.exe, we're going to see a whole lot of junk in here. And so some of these strings are readable, but a lot of them are not going to be. And so what ended up happening was if you tried to get to the underlying source code of this application, what you'd run into is what's called a PyArmor application. PyArmor is an obfuscator. It makes Python code really difficult to reverse engineer. Now, many of you tried that route. And that would be the more difficult way to try to solve this challenge. But let me show you the easier way. This is kind of a lesson in effective triage of malware. So let's go ahead and run Snake Eater just to start here. If we run Snake Eater, we get a blank prompt, and then we go right back to the command prompt here. So it looks like nothing actually happens. Something I want to point out, if you go ahead and do the -H, so the -H here, we actually get a usage statement for this program. So I left this in here intentionally because, a lot of tools have a -H to print out how you're actually going to use this. So if you were curious enough to see if there was going to be a usage statement, well, there you go. And immediately we notice that we have verbose mode here. All right, so let's go ahead and try verbose mode. So we get an interesting little ASCII Ouroboros snake here. We get some lyrics from the Metal Gear Solid 3 theme song, and we get here, looks good, smoke bomb. All right, so this is pretty cryptic, right? This is pretty classic in terms of kind of wacky CTF escapades, but let's think about what might be going on here. And one of the first lessons in triage is when you do dynamic analysis, you want to look at how this is interacting with the operating system. So one of the first things that we probably want to do is open up a little tool called Procmon. And let's go ahead and get Procmon running because that's going to show us the ways that this program is interacting with the operating system, the file system. It's going to show us all kinds of good information. The Procmon filters are the most important part here. So let's go ahead and set some filters here to just pare down like what we're actually looking at. We know the process name in this case is going to be snakeeater.exe, so we can actually just go ahead and add in Snake Eater like that. If we click apply, we shouldn't see anything yet because we haven't actually run this process yet. But if we run Snake Eater one more time in Procmon, we now see a whole bunch of information. Now, effective triage is all about isolating activity on the host and seeing what this file is doing. So up here in these 4 tiles, we can actually start to isolate the different types of activity. So let's say that we just want to look at network activity. We can uncheck all the rest of these and just get to network here. And in fact, we see that Snakeeater has no network activity, at least that we can see from the host. So we can uncheck that one because that's a dead end. All right, so what about registry activity? So there is, in fact, a lot of registry activity, but we find that this is all just kind of standard. And so maybe there's more interesting information in the file system activity. And indeed there is. So what we can do is look for anytime files are created or accessed. And so what we want to do is either sort on create file or sort off of the other ones that are not create file. So we can say exclude read file. We can say exclude close file. We're just getting rid of a lot of the noise here. I think query name information file is probably something we don't care about, so we can exclude that one. And this is kind of just the act of triage and paring down the information to kind of isolate what you're looking at. So let's go ahead and just exclude everything. Really, create file and write file are probably the ones that we're really interested in at this point. And let's just get rid of a few more of these. And query EAF file we probably don't care about, and query network open information file we probably don't care about. So we've got file create and file write at this point. So I think that's a pretty good start. So the idea with Snakeeater was that it would pick a random location on your file system to write the flag file. And we'll see this as a heuristic of malware when it's trying to find a location where it can drop maybe a second stage payload into your file system. So we can kind of resize this a little bit so we can see a little more. The path is probably the interesting one that we want to look at. So what we see after we get past this kind of like Python runtime setup is that Snakeeater is enumerating a lot of the directories that are in the app data location. So within app data, unless there's some weird edge case that I'm not aware of, every file inside of app data should be writable by the current user in that current context. And so what this is doing is it's going through and enumerating every single location inside of app data. For those of you that noticed that when you ran Snakeeater, your VMs or your PC slowed down a lot, this is the reason why, because it's enumerating all of these directories. But eventually it gets to the point where it finds a directory that it wants to write to, and that should be like one of the last things that happens here. And then look at that. We actually end up seeing that we're getting a flag written into that directory. So in this case, Snakeeater has called the operation to create file and query the information about the file, and then write the file into the C users, in my case, Husky, app data roaming, and in this case, it looks like it landed in Visual Studio Code. And so it writes a temp.txt file to make sure that it can write there, and then it deletes that temp.txt file and then writes the flag right there. So that is the flag for this challenge. And so that was the challenge. Snakeeater really, in this case, was just an exercise in using procmon to identify file manipulation from a malware sample. So that is Snakeeater. I hope you all had fun with that one. Let's keep it rolling. I'll see you in the next video.